Good evening to everyone. I am Nazma Makandar from BSc 3rd SEM SSGFC College, Naragon. My combination is CBZ. My assignment topic is nuclear chemistry, nuclear particles, positrons, neutrino, muons, pions, and quarks. Let us discuss about the concept. The first one, nuclear chemistry. The meaning of nuclear chemistry. Nuclear chemistry is the subfield of chemistry dealing with the study of nuclear particles, nuclear properties, and nuclear reactions. Or nuclear chemistry, it is the study of chemical and physical properties of the elements involved in the nucleus reaction, such as the radioactivity, fusion, and fusion which occurs within the atom's nucleus. Nuclear chemistry, it is focuses on the changes within the atomic nucleus and the particles involved, such as protons, neutrons, electrons, positrons, and alpha particles. And nuclear particles. Nuclear particles are the subatomic particles that make up the nucleus of the atom or are involved in the nuclear reactions. These included the particles found inside the nucleus as well as those emitted during the radioactive decay. P.A.M. Dirac, a British scientist, put forth his whole antiparticle theory, according to which there must be present in the universe not only the familiar particles such as electrons, protons, and neutrons, but also antiparticles which in their properties are opposite to the familiar particles, thus corresponding to the electron, proton, and neutron. There must exist anti-electron, anti-proton, and anti-neutron. The first nuclear particle we discuss about positron. It is the first antiparticle discovered by the Carl David Anderson at 1928. The positron is the antiparticle or the antimatter counterpart of the electron. Thus, it is referred as the anti-electron or positive electron. It is the positively charged and subatomic particle having the same mass and magnitude of the charge as the electron. It is represented as atomic mass and atomic number of an element. The example, carbon having 11 of atomic mass is an example which emits a positron. 0 protons and 0 neutrons is equal to 0 for the atomic mass and 1 positron is equal to +1 for the atomic number. Key properties of a positron. The first one, charge. The opposite of an electron charge, so it is a positive charge, +1. Second one, mass. Identical to the mass of an electron, approximately 9.11 into 10 to the power of -31 kg. Third one, spin. Like the electron, it has a spin of half. Fourth one, role. It is a form of antimatter. Production and behavior. Point number 1, beta plus decay. A proton in a neutron rich nucleus transforms into a neutron emitting a positron and a neutrino. Point number 2, pair production. A high energy proton can vanish create a electron positron pair. Point number 3, annihilation. When a positron encounters as electron, both particles are destroyed and their mass is converted into energy, typically in the form of gamma rays. Its applications. First one, positron are used in a medical imaging techniques called positron emission tomography (PET), which tracks metabolic activity in the body. Second, material studies. Third, fundamental research. Fourth, radiopharmaceuticals. Let us discussing about the second nuclear particle, neutrinos. A neutrino is a neutral subatomic particle which very small mass, almost zero, and no electric charge. It is represented by the symbol of V. Neutrinos are produced during the nuclear reactions such as beta decay, fusion in a sun, and supernova explosion. Because they have no charge and interact very weakly with matter, they can pass through almost anything without being stopped. Examples of formation: beta decay. Their weak interaction is exploited is radiochemical experiments where they can be captured by the atom to cause inverse beta decay, a reaction that transforms the atom into different elements. Types of neutrinos. First one, electron neutrino. It represented as VE. Second one, neon neutrino. It represented as V mu. Third one, tau neutrio. It represented as VT. Applications of neutrinos. First one, astrophysical and cosmology. Second one, nuclear reactor monitoring. Third one, earth and geoscience. Fourth one, medical and biological research in experimental. Fifth one, particle physics research. Let us know about the third nuclear particle, meson. A meson is a subatomic particle that is a composite of the quark and one antiquark bound by the strong nuclear force. Mesons to explain the short-range attractive force existing between protons and neutrons in the nucleus. Meso meaning middle in Greek is to be unstable with the mass intermediated between that an electron and a proton. Mesons are hadronic subatomic particles composed of one quark and one antiquark bound together by the strong interaction. Because mesons are composed by the subparticles, they have a physical size with a radius roughly 1 micrometer, is about 2 by 3 the size of proton or neutron. There are three types of mesons found both in cosmic rays and in the laboratory. There are mu mesons, pi mesons or k mesons. First one, mu meson has a mass of electron is equal to 0.0005486 AMU and a charge which may be positive or negative. Second one, pi meson has a mass about 270 times that of electron and a charge which may be positive, negative or zero. Its half-life period is 2 into 10 to the power of -8 seconds. Third one, K meson has a mass about 970 times that of electron and that may be positive, negative or zero. Its half-life period is 1.2 into 10 to the power of -18 seconds. All mesons are unstable with the longest lived lasting for only a few hundredths of microsecond. Charged mesons decay to form electrons and neutrons. Uncharged mesons may decay to protons, example pions and kaons. And third nuclear particle is pions. Any of the three least massive mesons having a positive, neutral, or negative electric charge are called as pions. A pion is denoted by pi, and the three subatomic particles are denoted as pi plus, pi naught, and pi minus. The charged pions have a mass 273 times that of an electron and mean lifetime of 2.6 into 10 to the power of minus 8 second, and the neutral pions has a mass 264 times that one of an electron as and mean lifetime of 8.4 into 10 to the power of minus 17 second. Each pion consists of a quark and an antiquark, therefore points are also called as p-meson. Pions are the lightest mesons and play an important role in applying the low energy properties of a strong nuclear force, that is, attractive force between the nucleons. Charged pions tend to decay into the muons and neon, neutrinos, and neutral points into a gamma rays. Pions are not produced in radioactive decay but are produced commonly in high energy accelerators in collisions between the hadrons. All types of pions also produce a neutral process when high energy cosmic rays, protons, and other hadronic cosmic ray component interact with in matter in the Earth's atmosphere. Fifth nuclear particle, quarks. Quarks is a elementary particle and a fundamental constituent of matter. Quarks combine to form composite particles called hadrons, the most stable of which are proton and neutron, the component of atomic nuclei. There are 6 types of quarks, which up, down, strong, charm, bottom and top quarks. Up and down quarks, through a process of particle decay, the transformation from a higher mass table to the lower mass table. Because of this, up and down quarks are generally stable and the most common in the universe, whereas strong charm top and bottom quarks can only be produced in a high energy collision such as involved cosmic rays and a particle accelerates. For every quark particle, there is a corresponding type of antiparticle known as antiquark that differs from a quark only in the sum of its properties have equal magnitude and opposite sign. Thank you.